Hello and welcome to the plotting tutorial in MATLAB in CS 4010. I know that all of you have started MATLAB before, but this is just the first tutorial in this subject and we try to revise some basic knowledge to warm up. To start a program in MATLAB, you need to click on New and create a new script. To start a new program, we need to have to clear the memory, so I just use clear and then close on to close on the current figure or picture, something like we are using. You can choose not to do it, but if you don't do it, the memory still there, so maybe the old variable may infect on your new variable, so I recommend you to do that. Now to do plotting, the first step we need to create a new figure. So this command helps us to create a new figure. If you want to specify the number of the figure, for example, figure 1, figure 2, figure 3, you can put the number inside the brackets. However, if you don't have any specific requirement, I recommend you to leave it blank. So therefore, it will create a new figure. And now in the first module, we study how to plot a 2D function. To plot a 2D function, we need the x and y value. So we declare the x range first. So if you don't declare it, you cannot plot because the MATLAB, the program, couldn't know what is the range of your coordinate graph. So I think there are many ways in MATLAB, but the most easy way is just I declare it directly. For example, I declare it from 1 to 10, and I have to declare the step as well. So 0.1. This one I declare the x range. Now just run it to see what happens. So now you can see I have created a new figure, and by default it is figure 1. If figure 1 exists, it will be figure 2, figure 3, something like that. And because I haven't plotted anything, so the figure is blank. And I have a variable named x here. And if you click on this, you can see my range of the variable. So from 1, 1.1, 1.2, 1.3, something like that. Now I need the value of y, which is a function of x. For example, I try to plot the cubic functions. So will be x dot to power of 3. So this is the way how we declare the polynomial function. So in here, you can see that I have a dot over here before the power sign. The dot means every single element in the x range will be cubed. Let's see how it works. So I have to plot it by the command plot x and y. So now you can see here is my graph of the functions cubic x from 1 to 10. I think it's all good to me. There are many other basic functions in MATLAB, for example, the trigonometric functions. If you want to continue your command, you just put the ellipsis here to hint that your function will be continued in the next line. For example, I can add tan x is for the trigonometric function, and it can be, for example, log. It's a natural log of x over log of, for example, 3. So this will be the log, the base 3 logarithm of x. And may, for example, you can keep divide on something like the exponential of x. And what else we can do? Maybe factorial. So this is factorial should be start with factorial of x, but it's we should do floor x because x is not an integer, and sometimes we need some default value. So we need some default value, for example, a pi value. Now let's see what happened with this one. Sometimes you have a plot. So okay, so I need a dot here because this one I need to work on each element when I time with something. You know, when I do the tan x or log x, I don't need a dot over here because you certainly cannot do a tangent of an array. You have to do tangent of a number, and the same to log. But when you try to time it with something, so you may need to time it with element by element. So you need a dot right over here. I know it's confusing, but you have a try and you will be familiar with it, very similar. Just remember, if you can do the matrix operations, you just need to remind to put the dot there, and it cannot be done with a matrix, so you don't have to put a dot there. Just run it. So here is my functions. Now, sometimes you know you want to have many plots in one finger. So in this situation, we need to do not only plot, but we need to do the subplot. To declare a subplot, we just use a subplot. For example, I use 2, 2, and 1. That means I have a range of 2 by 2 plots, and this is my first plot. Yep. And let me see. So now you see I have the space for the second, the third, and the fourth plot, but I use only one for the first plot. Sometimes you don't have to use plot. You can use, for example, Semilog. So I use Semilog y because my y value is really big. Try to see what happens if I can use this one. So now you can see the x-axis is a normal one, but the y-axis is in logarithmic scale. And you can see that it's negative data because you cannot plot the negative data on a log one, so it's going to be ignored. And if you want to keep drawing on this subplot again, you can just use hold on. That means you want to keep drawing on this, and when you don't want to keep drawing on this, you just press hold off. So it will no more drawing on the same data. When you start a new drawing, it will erase all of the existing data. To decorate for your plot, you may want to do something like legend. So you can legend, for example, it will be function. So you declare the legend for the line. I forget the dash over here. Actually, it's called apostrophe. Okay, I declare the legend for the line. And I also can declare the title for the chart as well. So I declare it as an example. So I set title for it. And sometimes I want to do the equal axis, so I just type axis equal. But in this problem, I don't have equal axis, so I don't need it. Now let's see how the new one will look like. So you see, this subplot has the example and the function legend for the line. So that is a 2D example. If you want to do on others, you can see how to make this one, for example, markers or line split and some other color code over here. Just go to MATLAB and search for plot. You will have a lot of options. Here is option for the plot command. Okay, so now we move to the next module. I'm going to plot a contour. Yep. So to plot a contour, I will plot not only x and y value, so it kind of a 3D functions, but it displayed in 2D. So for that one, I need to declare the x range first. So the second way how you declare a range, apart from what you have learned before by directly type it out, we can choose a command named Linspace. And I declare the first point. For example, I go from -2 to 2. And I need about 40 numbers in this range. So I declare x range with 40 nodes. And the same thing to y, I declare it with Linspace from -3 to 3, and I have about 60 nodes. So this way I will have the delta x and delta y as the same value. Yep. Now, when I have the x range and y range, I can plot a 2D functions. But this way I plot to 3D function. So therefore I need to make a mesh grid from that. So it will form a matrix of x and y coordinate for every single dot, single plot. So it will be something like that. Please you capitalize so you will not be confused with your x and y range later. This is a mesh grid of x and y. Okay. Now let's try to see what happened with this one. So now I have the x variable which come from -2 to 2, and I have 40 nodes in here. And I also have the x capitalized and y capitalized variable. If you click on here, it will be a matrix of the coordinate x and y. So on the first column, we have the same x coordinate. On the second column, we have the same x coordinate as well. And it's the same to the y variable. So all of the first row has the same y coordinate. All of the second row has the same y coordinate. You see that? So it's a mesh grid, and we can plot based on this. Now, I just declare a 3D function. For example, I declare it a z, and I capitalize so I don't be confused with the 2D functions. I will get this one, the basic function in MATLAB. So x dot times by the exponential of minus x squared minus y squared. Please remember that the dot means that you will work with the element, not the array, but you will work with all elements in the array. So this one I create a mesh grid for 2D plot. And at the step it just be a contour plot. And in here I just compute the function. Now I can start do that by I do another subplot 2, 2, and it's my second plot. move to the second plot, and I can just plot it by the contour x, y, z. Okay. Now let's see what happened with this one. Now you see that I have in the second positions the second contour plot, and it has different color for different values. I want to see the values of this one, so I want to fill it as well. So for example, I can make show text, so I will see the text of the plot value and on, so I will see it. And if I want to make it a fill contour, just use Ctrl F. So plot a fill contour and see what happened with that. Now you can see my plot is filled. It has a text to show me the value on each contour. Now that is for contour. Now I try to move to the 3D plot. Okay. To do 3D plot, I need to move to a new subplot. So this will be the third one. And this is my third subplot. And I use the command surface x, y, and z to see this one. And I have to move to view 3 to have a 3D view. So plot a 3D surface. Move to 3D view. Yeah. Now to see. So now you can see that I have a surface plot, and it's in 3D view. I can rotate it to see. I can set the legend and the example as I did before. I think it's all good to me. Now, the good thing of MATLAB in comparison with some other graphing tools like Excel is that it can do the data processing really easily. So we move to the next module. We do data processing. So for example, when you have some noise in your graph and you want to edit it, you must do some matrix operations on the data you have. For example, in here, I think I want to trim off all of the value which is larger than 0.3. So I use z larger than 0.3. So this condition will address all the elements in z if they are larger than 0.3, equal to 0.3. For example, like this. And I subplot 2 to 4, for example, like this. So this is my fourth plot. And this one is I do some data processing. And then I build it, surface, x, y, and z. And I change to 3D view. Now let's see what happened with my code. Now I have 4 subplots, and you can see that this is the original data and this is the process data. When I trim off all the values that is larger than 0.3, for example, maybe it's due to some error in the measurements, or maybe it's something illogical, I just trim it off, for example, like this. And I think that is for this tutorial. We just revise quickly how to do the 2D function plotting, how to plot a contour, how to plot a 3D surface, and how to do data processing for what we have. If you want to have more information, please go to MATLAB and search for the plot for all the 2D plots. And you also can have a look at the 3D plot. Yeah, some kind of rendering, different type of plot. And you may also want to have a look at how to operate with the matrix, because matrix operation is very important for data processing. And that's it from me today. I hope you enjoyed the tutorial. Thank you for attention and see you next time.